is on greatest common factors using a factor tree. So today we are continuing to study greatest common factors, and this is a second method to find them. So our learning target today is I can find greatest common factors using a factor tree. Please write down the date that you're watching this video. This is to help you keep your notes organized. Write down your I know statement. You know how to find a greatest common factor using a list. That was what we learned in the last video. So now you are going to learn how to do it another way. So you could write down that you know how to do it with a list. Might be a good thing to write for your I know. And we have one vocabulary word. Our vocabulary word is relatively prime. Relatively prime is two or more numbers with a greatest common factor of 1. So please write that down. Pause the video here if you need to get caught up on all that. And then when you're ready, you can continue. So we're talking today about finding the greatest common factor using a factor tree. So this is a method that is really, really straightforward to use if it makes sense for you. And if it doesn't, you can always go back to using the list. I think the list makes the most sense. And this method is sometimes a little bit more straightforward. And you're always confident that if you did it right, that you have the right answer. But at the same time, for some people, this is a really confusing one. So again, I'm going to teach you this method. You'll have them 2 methods, and you'll be able to choose which one you like better, whether it's the list or whether it is the tree. Okay? So let's say I asked you to find the greatest common factor of 90 and 150. Okay? To do that, we're going to take the number 90 and we're going to take the number 150, and we're going to write them like that on our page. Now, if we were using a list, we would list all the factors, find which ones they had in common, and then pick which one was the greatest. However, today we're using a factor tree. So to start, instead of just listing factors, we're going to make a factor tree. So for making my factor tree for 90, if you remember this from the prime factorization video, we just picked 2 numbers that would multiply to give us 90. There's multiple ways to make your tree, but they should all end up with the same prime factors at the end. So for 90, I have 2 and 45. 2 is prime, so I continue with 45. For 45, I have 5 and 9. 5 is prime. And then for 9, I have 3 and 3. My 3s are prime. My prime factorization now is 2 times 5 times 3 times 3. Now we know, because I showed you before, that we don't actually like to write it like that. We want to write it in least to greatest. So it's 2 times 3 times 3 times 5. Now we could take this even one step further and do 2 times 3 to the second power times 5. But for this method, we don't really even actually need to do that. We're going to actually just stick with using this one right here, and that's going to help us. So 2 times 3 times 3 times 5. We could do the same thing with 150. So we want to come up with a pair of numbers that will multiply to give us 150. The easiest one that I see right away is just 15 and 10. You know, you could do 2 and 75. You could do 5 and, whatever, going from there, 30, I think. But we're just going to do it this way. So 15, I know that that's 3 and 5. Those are both prime numbers, so I can stop there. 10 then is 2 and 5. Those are both prime numbers as well. So writing these in least to greatest order, I have 2 times 3 times 5 times 5. Which again, I could shorten to 2 times 3 times 5 to the second power, but I don't actually want to do that for this video, for this method, okay? So, to find the greatest common factor, we are now going to look at all these prime factors, and we're going to find all the ones that we're going to have in common. So we want to find all common factors. Okay? So if I do that, I say, okay, 2, that's common. So I have a 2. 3 is common. And I have a 5 that is common. This 3 I can't take because it doesn't have a pair on the other list. And this 5 I can't take because it doesn't have a pair on the other list. Okay? So now that I found all the prime factors, 2, 3, and 5, to find the greatest common factor, I'm just going to multiply those. So I'm going to do 2 times 3 times 5. That equals 30. And that is my greatest common factor. So all I had to do for my first step was make factor trees. Then I had to find the common prime factors. And step 3 is multiplying those factors together. Okay? This method only works when you have 2 numbers that you're doing it for. This method is not going to work nicely when you have 3 or more numbers. So when you have 3 or more numbers that you're finding the greatest common factor for, always use the list. But this method, the nice thing about it is that instead of sitting and listing factors for a long time and hoping you find them all, as even you saw made a mistake when I was doing that video, this method lets you be really, really confident that you found everything as long as you did your trees correctly. But again, for some people, this is a very confusing method. So we'll do one more example here. And this method really works best when we're looking at really big numbers that you don't really want to mess with. So let's say, for example, we did 84 and 216. And we wanted to find the greatest common factor. I don't know about you, but when I see 216, that's kind of a big number. And I'm not sure I'm going to know all of its factors right away to make a list. So that's why this might be a good one to do with the trees. So making trees for each of these, and if you want, pause the video here, see if you can solve the problem on your own. Otherwise, we'll continue together. 84 is an even number. So for all even numbers, I like to do 2. And then 84 divided by 2 is 42. 2 is prime, so I'll highlight it. And then move on to 42. For 42, it's still even, so I'll divide it by 2 again. 42 divided by 2 is 21. 2 is prime. 21, I know, is not prime, so I won't highlight it. 21 then isn't divisible by 2. It is divisible by 3, so I'll do 3. And 3 times 7 equals 21. So I have my 3 and my 7. And those are both prime. So my prime factorization is 2 times 2 times 3 times 7. Okay? Now I can do the same thing for 216, making my tree. 216, again, it's an even number, so I'll do 2. And then it's 108. 2 is prime. 108 becomes 2 because it's an even number. And 54. I like dividing by 2 because it takes a lot of the guessing out. 2 again is prime. 54 is not. 54 still even, so I'll do 2 again. 54 divided by 2 is 27. 2 is prime. 27 is not divisible by 2, but if I do 27 divided by 3 on my calculator, I get 3 and 9. 3 is prime. And 9 comes out to 3 times 3. That's kind of a big tree there. But we seem to have everything now. So here we have 2 times 2 times 2 times 3 times 3 times 3. Again, just writing down the prime numbers that were at the ends of the branches. Okay? So that was my step one. I made my factor trees. Now I need to look for the common factors on both of them. So what numbers are common? I see that I have a 2 and a 2. That's common. I have another 2 and another 2 that are common. And then this 3 and this 3, those are common. My 7 doesn't have a common person on the other side, so they don't match. And then none of the 2s or 3s that are left over here have anything in common, so we're done. So the numbers that had a common were 2, 2, 3. Okay? Now to multiply those together, times 2 times 3, and that gives me, that means my greatest common factor is 12. Last thing I want to point out for this video is sometimes you're going to get two numbers that don't have anything in common. So one example would be 49 and 36. If I made trees for both of these, 49 is 7 and 7, so just 7 times 7. 36, well, I know that's 6 times 6, which would be 2 and 3 and 2 and 3. So this would be 2 times 3 times 2 times 3. As you can see, they have nothing in common. Okay? What that means is that these have a greatest common factor that equals 1. Which means that these two numbers are called relatively prime. So if you're ever working on a problem and you get to a place where you say, there's nothing that's common, there's nothing on both of those lists, that means the two numbers that you're looking at, in this case 49 and 36, those are called relatively prime. Please let me know if you have any questions. Have a great day.